Below are some functions and their antiderivatives. Use inductive reasoning to identify the pattern, and then continue the pattern. So we see that x has an antiderivative of x squared over 2 plus c. X squared has an antiderivative of x to the third over 3 plus c. And x to the third has an antiderivative of x to the fourth over 4 plus c. Clearly there's a pattern here. All I want to do is continue the pattern that's already there. And what I see is that we're adding 1 to the exponent and then dividing by that same exponent and then putting plus c. So the antiderivative of x to the fifth may be x to the sixth over 6 plus c. And we'll just keep going like that. It turns out this is an important rule in antidifferentiation, called the power rule for antidifferentiation. So now what I'd like to do is write the power rule generally. And here we have a function f of x equals x to the n. So what I want to do is add 1 to the exponent and then divide by that same expression and then add c. It's the reverse of the power rule for differentiation. Okay, so here it's written in just a little bit different way, but it's going to be the same formula. Now notice that our exponent cannot be negative 1. Because if it was, we would be adding 1 to that, and it would be a result of 0, and we can't have division by 0. So this power rule will work for any exponent that's real as long as it's not negative 1. Let's try it here on the square root of x. We want to take the antiderivative of it. And let's rewrite it with a rational exponent. The square root of x is the same as x to the 1/2. And so we just have to add 1 to the 1/2. That's going to be 3/2 over 3/2 plus c. That's following the rule from above. Now we could simplify that if we wanted, and sometimes it is just sort of nice to simplify it. Makes it easier to work with. So instead of dividing by a fraction, we'll multiply by its reciprocal, right? So our final answer could be x to the 3/2 times 2/3. All right, let's find the antiderivative of x to the e. Well, following the power rule from above, we'll do x to the e plus 1 over e plus 1 plus c. And that's as far as we can go, really. Okay, now we'll try x to a negative power. going to be x to the negative 2 plus 1 over negative 2 plus 1 plus c. Now that's going to give us x to the negative 1 over negative 1 plus c. And then we'll just get the negative from down below. Let's put that up top. And since our x has a negative exponent, let's move that x down below. Now it's totally simplified. And it looks good.